Welcome to The Explainer, everyone. Today we're diving into literally one of the most universally stressful, blood pressure-raising problems in the entire world of software development. I'm talking about the slow database query. Right? If you write code, manage databases, or keep any backend system breathing, you know exactly what I mean. We're going to look at a pretty fascinating tool called sql-doctor. Get ready, because we're about to see how this thing takes a process that usually results in hours of pulling your hair out and turns it into a totally smooth, instantaneous check.
So, have you ever felt that cold sweat? You know the one, it's 4 p.m. on a Friday, or maybe you're right in the middle of a massive product launch, and suddenly the whole system just grinds to a halt. The alerts are firing off, Slack is absolutely lighting up, and you're just sitting there staring at this massive, complex SQL query, trying to figure out why on earth it's suddenly taking 10 seconds to run instead of 10 milliseconds. The clock is ticking down, everybody's asking you for an ETA on a fix, and the pressure is squarely on your shoulders. It's just a terrible, terrible feeling.
And honestly, that pressure, it's completely justified, because a slow query is never just a red line on some internal engineering dashboard. When databases slow down during peak load, it directly hits real transactions, and more importantly, real customers. People literally can't check out of their shopping carts, critical reports just refuse to load, and the whole user experience goes right down the drain. The actual business cost of a bottleneck like this is incredibly high, which means the speed at which you diagnose and fix it is absolutely crucial. But here is exactly where the traditional debugging process totally breaks down. Diagnosing a slow query usually means you have to run an explain plan in Postgres. And if you've ever looked at raw explain output, well, you know it is unbelievably dense. It takes deep, highly specialized expertise to sit there and manually reason about index behaviors, or disk spills, or node costs. So what ends up happening? The whole team gets completely bottlenecked. Out of a team of, say, 50 engineers, maybe only a handful can actually reliably read and decode those cryptic execution plans. So everyone else basically just sits around twiddling their thumbs, waiting for that one database expert to finally free up. Okay, let's dive into this, because this brings us to the exact paradigm shift we are exploring today. We are moving away from those hours of agonizing manual investigation, waiting on that one senior engineer, and squinting at raw text outputs. Instead, we're stepping into the new reality that sql-doctor brings to the table: instant, automated diagnosis. We're talking about taking a workflow that is notoriously manual, painfully slow, and super error-prone, and turning it into a deterministic, automated check that absolutely any developer can run completely on their own. So what exactly is this thing? Well, sql-doctor is a standalone application. It actually comes as both a really slick desktop GUI and a command line interface, or CLI, for your terminals and CI scripts. Basically, it automatically diagnoses slow PostgreSQL queries by analyzing the actual real execution plan. And here is a massive detail that really stood out. It runs completely offline. Zero external servers to spin up, you don't have to create some cloud account, and there are absolutely no intrusive agents you have to install on your production database. It literally runs entirely right there on the developer's local machine.
The whole workflow is just a beautifully simple, completely frictionless three-step process. First up, you connect to your database. Second, you analyze. You literally just paste in your slow query, hit go, and it instantly runs its deterministic checks. And third, you fix. You're not just getting some vague warning here. You get the concrete SQL to solve the problem right then and there. Let's actually break down each of these steps so you can see exactly how they look in practice.
Starting with step 1, the connection. The UI for this is super straightforward. You just point it right at your database. But from a security and IT compliance standpoint, it is incredibly well thought out. The connection it makes is strictly read-only. And on top of that, your passwords are never saved to disk. They're just entered for that current session. That means sql-doctor can easily slide right into existing, super strict enterprise IT policies, like the ones you'd find at a bank or a healthcare company, without needing you to jump through a million hoops for security approvals. Once you're connected, we move right into the analysis phase. When you paste your query in, the tool runs an explain command, specifically looking at analyze, buffers, and formatting as JSON. But here's the magic. Instead of forcing you to read that massive wall of JSON, it takes that real execution plan and deterministically matches it against a built-in library of over 30 anti-pattern skills. We're talking about the greatest hits of database performance killers here. Things like missing indexes, inefficient joins, weird aggregation and sorting issues, partitioning problems, disk spills, repeated scans inside loops, the whole shebang. And it doesn't just guess. It uses hard-coded text-based rules that are verified by deep database engineering expertise. And the output you get from all this is just brilliant. sql-doctor doesn't just toss a cryptic error code your way and wish you good luck. Instead, it gives you high-priority findings explained in plain, everyday English. For example, if it detects a missing index, it actually explains why it's an issue, pointing out that a sequential scan is filtering way too large of a table. But the absolute best part? It hands you the exact, concrete SQL statement you need to fix it. We're talking copy-paste ready commands like create index concurrently. It literally moves you instantly from a diagnosis straight to a doctor-prescribed remedy. Now, what's really interesting about this slide is how the tool actually handles the explain plan itself. For the folks who really want to get under the hood and see exactly where the time goes, there is no raw explain output to decode here. Instead, every single query plan is rendered as this beautiful, interactive visual hierarchy. And automatically, based on those 30-plus anti-pattern scales, it highlights the exact problem nodes in bright red. So you can immediately trace the issue straight down to, say, that one sequential scan that's bottlenecking the entire operation. It takes the totally invisible mechanics of your database and makes them completely visible.
But you might be wondering, what happens if your query has some totally unique issue that doesn't perfectly match one of those 30 built-in skills? Well, the tool actually has a pretty amazing fallback mechanism, a schema-grounded LLM hypothesis feature. You can hook it right up to a local Ollama model, Claude, or Azure OpenAI. And the absolute most crucial point here is that there is zero hallucination risk. Because this is a serious tool for serious databases, any identifier or column name the AI suggests is automatically validated against your actual database schema before you ever even see it. So you get all the immense reasoning power of AI, but it is completely grounded in your real verified environment. All right, let's pivot and talk about how all of this actually translates into real-world results. Because let's be honest, a diagnostic tool is only as good as the performance gains it can actually deliver, right? And everything we're talking about here is not just theoretical. The performance claims for sql-doctor are measured, not estimated. They've been rigorously verified end-to-end against production-scale data. We're talking hundreds of thousands of rows using real PostgreSQL execution plans. Let's actually take a look at the speedups this tool achieves when it hits the real world. A 3-time speedup, that is our first verified metric. In a real-world scenario tested by the developers, sql-doctor instantly detected a missing index. And by simply applying the plain English fix that the tool automatically provided, the query execution time plummeted from 27.8 milliseconds down to just 8.6. That's a 3x increase in speed. And it was achieved not through hours of manually hunting through logs, reading docs, and testing random theories, but in literally seconds of automated checking. And honestly, it gets even better. A 6-times speed up. In another documented case, the tool flagged a really inefficient subquery and provided the exact concrete fix to rewrite it as a join. When they applied that single automated suggestion, it completely slashed the query time from 204 milliseconds all the way down to a blazing 34 milliseconds. I mean, just imagine applying a 6x speedup across your most heavily trafficked production queries. The impact that would have on your server load and your end user's experience would just be absolutely massive. Which brings us to our final takeaway, and a thought I really want to leave you with today. We've just seen how sql-doctor safely, securely, and instantly decodes incredibly complex database plans. So ask yourself, if you could take hours of stressful, panicked database debugging and turn it into a 10-second deterministic automated check, what would your team actually build with all that reclaimed time? By completely removing the bottleneck of database expertise, you're empowering every single developer to write faster, better code. Thanks so much for joining me on this explainer, and I really hope this dive into sql-doctor gives you a powerful new way to think about your database performance.